Welcome to the DIY Honda Garage channel. DTC P0722 refers to a malfunction associated with the output shaft speed sensor, indicating there is no signal input. This diagnostic trouble code is significant as it can lead to improper transmission functionality, affecting overall vehicle performance. The output shaft speed sensor, also known as the countershaft speed sensor, is crucial for monitoring the rotational speed of the output shaft in the transmission. Its signal is vital for the transmission control module to adjust shifting and optimize transmission performance. Diagnosing and addressing this code must be done methodically to ensure proper vehicle operation and avoid unnecessary part replacements. Before proceeding, it's important to record all freeze frame data and onboard snapshots using the Honda Diagnostic System, HDS, as this offers insight into vehicle conditions at the time the DTC was triggered. DTC P0722 indicates a lack of signal from the output shaft speed sensor. This sensor is responsible for measuring the speed of the output shaft, which in turn informs the transmission control module about the transmission's operating conditions. The sensor is typically located on the transmission housing, specifically around the output shaft area. The data it provides is fundamental for the electronic control unit to make proper adjustments during gear shifts. If the sensor fails to deliver this information, it may lead to issues such as erratic shifting behavior or even transmission failure. Thus, understanding the functionality and importance of this sensor is crucial for effective troubleshooting. The primary cause of DTC P0722 is an electrical circuit problem, and it's essential to note that this issue does not stem from mechanical faults within the transmission system. Typically, the first aspect to check is the VCC1 line, which may have experienced an open circuit. If the wires connected to the output shaft speed sensor are damaged or disconnected, this can prevent the sensor from sending signals to the PCM, powertrain control module. Another potential cause could be a malfunction within the output shaft speed sensor itself, whether due to physical damage or internal faults. Identifying which of these issues is present is critical to resolving the DTC effectively. When DTC P0722 is present, drivers may notice various symptoms impacting vehicle performance. One prominent symptom is erratic shifting, where the transmission struggles to properly engage gears, causing a jarring or delayed response. This can significantly hinder the driving experience and make the vehicle less safe. Additionally, the check engine light will typically illuminate on the dashboard to alert the driver of a potential issue, indicating the need for diagnostics. Other symptoms may include reduced fuel efficiency or an inability to accelerate smoothly, all of which suggest that the vehicle's transmission is not functioning as designed. Addressing this DTC promptly can often restore normal driving characteristics. The first step in troubleshooting DTC P0722 involves problem verification, which is crucial for confirming the existence of the issue. Start by turning the ignition switch to the on position. This action allows the system to initiate self-checks. Use the Honda Diagnostic System, HDS, to clear the DTC, and then raise the vehicle securely on a lift so that the wheels can rotate freely. With the vehicle running and the VSA, Vehicle Stability Assist, disabled, operate the vehicle with the shift lever in D while maintaining speeds over 12 miles per hour, 20 kilometers per hour. Monitor both input shaft speed and output shaft speed using the HDS. If these values are similar, the issue may be intermittent. If the speeds differ significantly, this indicates a persistent failure that requires further investigation. Proceeding to the second troubleshooting step, It's crucial to check the VCC1 line for any interruptions. Begin by ensuring the ignition switch is turned to lock. Next, disconnect the output shaft speed sensor 3P connector to gain access to the circuitry. With the connector disconnected, turn the ignition switch back to the on position, which activates the electrical system but keeps the sensor out of the circuit for testing. At this point, measure the voltage between test points 1 and 2, one at the sensor connector's number 3 pin, which should provide about 5 volts, and the other connected to body ground. If you observe the correct voltage, this indicates that the VCC1 wire is intact. If not, continue by repairing any open circuits found between the sensor and the PCM. In Step 3, the objective is to determine the status of the NC line. Again, ensure the ignition switch is set to lock and the sensor connector remains disconnected. You will measure the voltage at test points 1 and 2, specifically at the number 2 pin of the sensor connector. This pin should also yield about 5 volts when the system is active. If the voltage is confirmed, proceed to the next troubleshooting step. However, if the test exposes a lack of voltage, further investigation into the wiring for issues along the NC line should commence. Step 4 focuses on verifying the SG1 line for continuity, which is integral for the signal path between the PCM and the output shaft speed sensor. As with previous steps, start by ensuring the ignition switch is in the lock position. With the connector still disconnected, you'll measure continuity between the test points that correspond to the number 1 pin of the sensor connector. The existence of continuity indicates the SG1 wire is functioning correctly, thus clearing that portion of the circuit from potential faults. If continuity is absent, repair any identified issues in the SG1 line to restore the intended signal path to the PCM. The 5th step revolves around checking the NC line for any potential shorts that may disrupt the signal flow. To initiate this process, turn the ignition switch to lock and use the HDS to jump the SCS service check switch line, which is a required procedure for running diagnostics. Once the SCS line is jumped, disconnect the PCM connector B to access the relevant wiring. At this point, measure continuity between the NC pin on the output shaft sensor connector and body ground. If continuity is found, it indicates a short to ground within the NC wiring. Repair should focus on this wire segment if issues are detected. After completing necessary repairs for DTC P0722, final repair verification is imperative for ensuring the problem has been resolved. Begin by reconnecting all previously disconnected connectors, ensuring each connection is secure and free from corrosion. Next, turn the ignition switch to the on position and use the HDS to clear the DTC from the system. With the DTC cleared, start the engine and disable VSA using the button as before. Drive the vehicle in D, while observing the speed readings from both the input shaft and output shaft using the HDS. If the speeds align closely, it indicates the issue has been rectified, signaling the completion of the troubleshooting process. Preventive maintenance is essential for avoiding recurrence of DTC P0722 and preserving transmission performance. Regular visual inspections of electrical connections can help to identify potential areas of concern before problems arise. This includes verifying the integrity of wires associated with the output shaft speed sensor and other related components. Additionally, monitoring sensor performance through regular diagnostics can reveal any irregularities early on. Ensuring that the sensor and its wiring are in good condition contributes significantly to the overall health of the vehicle's transmission system. By instituting these maintenance practices, drivers can help to extend the lifespan of their vehicle and enhance reliability. In summary, DTC P0722 signifies a critical issue with the output shaft speed sensor, particularly indicating a lack of signal input. The primary causes are typically electrical circuit issues rather than mechanical problems, emphasizing the importance of investigating the wiring and connectors leading to the sensor. Utilizing the Honda Diagnostic System, HDS, for diagnostic checks provides valuable insights into the vehicle's conditions, allowing for a structured approach to troubleshooting. By following detailed steps, from voltage checks to continuity testing, technicians can accurately pinpoint the fault and implement effective repairs. Preventive maintenance practices should be considered to reduce the chances of future occurrences, ensuring consistent transmission performance and reliability. Please like and subscribe to the channel. See you next time.